Hello everyone and welcome back to our channel MooTechie. It's great to have all the dairy technologists and students with us for this 5th class in Unit 2. In our last session we covered the various types of cream separators. Today we will explore two more advanced centrifugal machines, the triprocessor and the Bactofuge. We are now moving on to the topic of triprocessors. These are highly versatile machines designed to perform three functions simultaneously: separation, standardization, and clarification. They achieve a three-phase separation, handling liquid-solid mixtures. Key components of a triprocessor include a skim milk outlet with a pressure-regulating valve, a cream throttling or needle valve, and a cream flow meter to precisely monitor output. Here is how a triprocessor works. The volume of cream discharged is carefully controlled by the cream valve, which has a built-in flow meter. The pressure on the skim milk outlet is set using a regulating valve to a specific value, which depends on the separator model and the throughput. The throttling valve in the cream outlet is then adjusted to achieve the flow volume that corresponds to the required fat content in the final product. For large-scale operations, fully automatic inline systems are available. This slide shows a diagram of an automatic processing system for milk and cream standardization. It includes a density transmitter and a flow transmitter to continuously monitor the product. Control valves adjust the flows based on signals from a control panel. Other components include constant pressure valves, shutoff valves, and check valves. The system takes in whole milk and outputs standardized milk and standardized surplus cream with precise fat content. Now let's move on to the Bactofuge. This is a special clarifying separator that operates at very high speeds, up to 20,000 RPM, giving it extremely high separation precision. It is designed to remove microorganisms from milk based on their density difference. The principle relies on the different densities of milk components. Milk has a density between 1.028 and 1.032 grams per cc. Skim milk is denser at 1.036, while fat is lighter at 0.93. Crucially, bacteria are even denser, ranging from 1.07 to 1.13, allowing them to be separated out. Bactofugation is the process of removing bacterial spores from milk using this high-speed centrifugal separator, which can generate forces around 10,000 times gravity. These spores are not only difficult to inactivate by heat treatment, but are also heavier and denser than vegetative bacterial cells. The diagram shows the difference between a vegetative rod and a spore. The objectives of bactofugation are to improve the hygienic quality of milk, to avoid heat-resistant bacteria without resorting to excessive heating that could damage the milk, and to ensure an exceptionally high degree of bacteriological purity. The process is typically carried out at temperatures between 50 and 55 degrees Celsius. The reduction effect on bacteria is about 89 to 93%. If the milk is first clarified and then undergoes bactofugation, bacteria elimination can reach up to 99%. A double Bactofuge treatment, where the milk is first clarified and treated at 73 degrees Celsius, can yield an incredible reduction of more than 99.9% in the bacterial spore count. The efficiency of bactofugation is influenced by factors related to the microorganisms themselves and by process parameters and machine design. Microorganism characteristics that affect efficiency include their size, which ranges from 0.5 to 7.0 micrometers, their form, whether spherical or rod-shaped, and the characteristics of their outer surface, whether it is rough or smooth. Their density is obviously critical, as is their ability to agglomerate or clump together, either with other bacteria or with milk ingredients. The initial bacteriological quality of the milk is also important, as it may lead to chemical or physical changes that affect separation. Key process and machine parameters include the temperature of bactofugation between 50 and 68 degrees Celsius, which majorly affects the viscosity of the milk. The capacity of the machine, meaning the rate of milk flow, is important. The centrifugal force, determined by the machine's speed of revolution, is crucial. The space between the discs in the stack also influences efficiency. Finally, the design of the Bactofuge must avoid recontamination of the centrifuged milk after it has been cleaned. There are two main types of Bactofuges. The one-phase Bactofuge has an intermittent discharge for the collected bacteria. The two-phase Bactofuge has a continuous discharge system. The design of a modern Bactofuge is hermetic and self-desludging. It includes nozzles in the bowl wall for discharge. The microbial sludge called bactofugate is sent to a cyclone separator. To avoid the loss of valuable milk solids,